Today we are going to talk more about functions. And so far we have talked about deciding if a relation is a function by looking at all the different ways we can represent a relation or a function with tables, with graphs, with sets of points, with mappings. And then we have evaluated functions by plugging values into a function using the function notation like f of x, f with x in parentheses. And now we are going to try to match the correct function with its either graph or its table, or even take a word problem and write it as a function, which is something that we have done a little bit this year because we have written equations using words, and it is kind of the same idea. So here we have a graph of a function. This is a quadratic function, which we'll talk much more about in the future. But right now we are trying to match up which function rule, or which is what we call it sometimes, or which function equation matches this one. And for us at this point in the year, the way we are going to do it is by graphing them and seeing which one matches. And what I might suggest is I first find on my function some points that look like they're obvious to find. So some of these points are where they cross the x-axis. So places where my function crosses the x-axis is right here and right here. And in this particular one, the place where it stops going up and starts going down, so like the top of the roller coaster, that's an important point. And so when we graph these, we might want to look for those points in case there are a couple that look the same. So I have graphed all four of those options, and hopefully they look to you like they are different colors. And I'm going to try and show you both things at the same time. And my graph, my parabola, my quadratic function, which we'll talk more about in the future, it looks like it sort of opens downwards. So the one that it looks closest to is the one in purple. And I can see it has that point -4, 0. It crosses right here at 0, 0. And then the top of the roller coaster here is -2, +4. And so this one must be the function rule for this picture. And so right now we are practicing graphing these things in Desmos and matching the picture with the rule we have. So I have this one. And I'm sorry, you can see multiple pages, but I want you to be able to see the Desmos as well. So here I have just a line. So whichever function uh, I choose must be a line. And it looks like we have some points highlighted that it goes through. It goes through this one and this one, somewhere between 1 and 2 when it crosses this x-axis. And so I can keep graphing these, and you might want to do it one at a time. So I can graph the first option. Well, this line goes down to the right. This line goes up to the right, so it can't be that one. Okay, they both go down to the right here. And so I'm going to look and see where this line crosses here. Does it cross at the same place at the number 3? It sure does. And then it crosses somewhere between 1 and 2. It sure does. And so this is my function rule. And I can show you the other ones. That one goes up to the right. That's not going to be it. That one does go down to the right. It does cross this y-axis at the same place. However, you can see over here, it crosses a little further over than the picture I started with. So it has to be the blue one. So functions can be represented with function rules like equations. They can be represented using graphs like we've seen here. They can also be represented using tables, which we have already seen so far in this unit. And so we want to be able to match a table with its associated function rule. And there are a couple ways we can go about this. I think the best way is to graph all the options and then see which one all these points fall on. Whichever one of these is our function rule, all of these points will land on the line or the curve that's graphed. So one thing we could do is we could evaluate each of these for all of our x values. So when we plug 0 in, we should get 1. When we plug 1 in, we should get 2. When we plug 2 in, we should get 5, and so on and so forth. But what I'm going to do is I'm going to add a table. I'm going to hit this plus sign up here. I'm going to put a table in, click table, and I'm going to copy all my x's down. And then I'm going to copy my f of x's are actually y's, and so we can just leave that as y. And you can see that all those points get graphed. And so now what I'm going to do is I'm going to, if I press this button on the left side, it's going to show one of my lines. And the line that goes through all those points is going to be the function that this table describes, because those points have to be on the line if it's going to represent that table. So it's not this red one. It's not that blue one. It looks like it's the green one. I always like to check all the options. The purple one, it's definitely not the purple one. This green one goes through all of these points. This curve contains all 4 of those points in the table. That means they are part of my function. And so x squared plus 1 is the function this table is a part of. Let me do one more table. Again, I am going to just graph all these options, and I want to insert a table to put my points in. Remember that these x's and y's create coordinates, -3, -10. The first number is x, the second number is y. So when I make my table, my first numbers are x's. And then my f of x's are y's. They're sort of interchangeable. The reason we use f of x is because we want to show that you can plug an x value in. It's just a nice notation. It's going to graph all 4 of these points. The function rule that belongs with this table is going to be the one that goes through all of the points, because if a point is on the line, then it is part of the function rule. And I just like to look at them all. The first one is a no. Second one's also a no. Even though it goes through one of the points, it's got to go through all of them. Third one's also a no. Let's make sure the fourth one works. It sure does. That purple line goes through all of these points. That means that function rule, if we were to plug in all of our x values into this choice 3x minus 1, if we plug -3 in for x, we'd get -10. If we plug -2 in for x, we'd get -7. -1 would give us -4. So let me go, and you can see I didn't put f of x in there for these. And so if I'm not trying to evaluate, I don't need the f of x. I can just write the right side. But now I want to make sure if I evaluate f of x for -3, it gives me -10. If I evaluate it for -2, it gives me -7. So you can see we're creating these points that we said would be on the line, and they are on the line. -1 gives me -4, just like in the table, and 0, it gives me -1, just like in the table. Lots of ways to represent these functions and what they mean. Functions are always a collection of points, so we can always take some of the points and make a table out of them. We can evaluate them like we did in the last lesson. And in this one, we are matching up which graph or which table goes with which rule. That's rule is just another way to say equation. So another thing we'll do is we can write function rules for word problems, for actual scenarios. we can use the strategies that we used earlier when writing expressions, translating from words to expressions, or even when we were translating from words to equations. Same idea. We're going to highlight the important values. See if it'll let me highlight. Sure will. Important values. We want a function rule. And then it will define what our variable is. X is the number of hours. So we have a plumber. They're charging $75 for a service call. Service call is the $75 for the service call is sort of like a fee, like we talked about when we were doing expressions. A fee is a value or a quantity, an amount that you pay no matter how many hours this person works. And then they have an hourly rate. Hourly rate is sort of like saying per hour. And we talked about multiple times that this little 3-letter word per means multiplication. If we are told X is our number of hours and we're doing $50 per hour, that means somewhere in here we are going to have 50X. So our plumber charges $75 fee. It says plus, so we're going to use plus. $50 per hour, and it says in the problem that our hours is X. And so we might need the plumber for 1 hour. We might need the plumber for 2 hours. Maybe we need them for an hour and a half. And the way they are going to determine how much we owe them is they are going to plug in the number of hours for X. And so we can write this as a function rule by putting f of X at the front and putting an equal sign. X is our number of hours. So that means we can use this function rule to find, for example, how much will we owe if we have the plumber work for 3 hours. Well, just like we did in the last lesson, we could plug 3 in for X. We could tell the calculator, hey, this is my function rule. F of X equals 75 plus 50X. Can you now tell me what F of 3 is? And if we plug that in, we would get $225. So if you plugged the function into Desmos and then asked us what F of 3 is, we would get $225. And so this function rule would allow us, if we were the plumber, to determine how much do we charge our customer based on the number of hours we worked. So I have 3 for you to do. I have 1 graph, 1 table. Here are the answer choices. And 1 word problem. Here are the answer choices. Please pause here and try these on your own. There's no place to put them into the Edpuzzle. But I would like you to try these. It's okay if you get 1, 2, or all 3 wrong. That's totally fine. We're still in the learning process. But please do, if you get stuck, let me know. Pause right now, try these 3, and then press play to get your answers. So go ahead and check your answers. This last one was a little tricky, so if you struggle with that one, that's okay. We can talk about this together on how we come up with letter C. If you got one of these first 2 wrong, please do ask for help unless you've sort of realized your problem. And when you're ready, we have practice problems, so please move on and answer those 20 questions. Take your time, and as you're working through, ask for help when you need it. And whenever one of your answer boxes turns red because you got an answer wrong, please do raise your hand so that we can try and fix any mistakes before you practice the incorrect method more than once.